Recording. Well, yeah. All right. So today we're going to be talking about currying and decorators. So, but these two things let us do is basically allow us to have simpler but also more reusable functions. So I'll start off with currying. So let's say, what's a good example? Let's say that we're coming up with let's say we have a function called, I don't know, say hello, right? And I'll just leave it as a really simple function, say print hello. Super easy. If we run say hello, it'll output hello to our console, right? But let's say that we also want to make a function that says hello plus your name, right? So how can I modify this existing function? Well, let's say hello name. How would I create a function that I can input a name and that says hello and your name?
You could pass the name in as a parameter and then make an F string in the print statement.
Yep, pretty much, right? So we can pass in your name and we just put like a little space, then name, easy peasy, right? But now let's imagine that we have a way more complicated function in the back. Like it's not just saying hello. Let's say it's like saying hello, but then it's also like pulling some data from an API and creating graphics and who knows what other stuff. And we need to create another function that not only runs that function, but that also modifies its behavior. And we need these to be two completely different functions. So a simple way to do this would be we can create a new function. We could say hello name. So we don't really need to do this. And then we can just say hello and then print your name, right? So this is like the traditional definition of sorts that we've seen of just normal, like combining functions normally. So we can layer functions, right? We can create functions that are defined inside of each other. We can call functions inside of other functions. That's the way that we're going to be using functions most of the time, pretty much in any language. But let's say that we had a function that let's say we modified our say hello function. So delete this. We say hello. My name is, to make this an F string, and then we say wrong button. F, then name. I am IH. Right. So this could be we could write this function, and then we say my name and my age are its parameters. Now, let's say that we are running, we have this function, but instead of, for example, setting my age to be a variable, what if for all of our use cases, like the only people using this application are all like 12 years old, for example, right? So we can't really define a function. Well, there are a couple of ways we can do it. One way is say hello 12. And here, let me go back. And then we could say my name. And then you could just say, hello, my name, comma, 12. Right, so that way it always replaces my age with 12. But there's a few other, I guess we could say more complicated ways that we could do it. Because, I mean, sure, here we have say hello 12, right? But let's say we come up with another use case where everybody who's using this application is like 25. Then another one where everyone's like 72, and so on and so forth. And it gets a little bit more complicated. So we can rewrite our function for say hello to allow us to create sub-functions of sorts that take in different inputs like this. So we would have say hello that just takes in my name, and then we could say like say hello age that takes in my age. And let me just define this as a sub-function. So what we're doing here is, again, I'm just putting in one function inside of another function. That's all we're doing here. And here, instead of print, let's just return this, go to the end. And then say hello is just going to return say hello age, and yeah, that should probably work. So if we want to see how this works, we can print say hello and say name is Bob, I am 25. Right? So if we go and run this, hopefully this should show up in my terminal. Let's see. One positional argument, but two were given. Oh, I see. Okay. So sorry, this approach would work for the original say hello. Let me do that because we wrote the function definition. That's what I was trying to run. So yeah, here we have, it prints out hello, my name is, take Bob from here, that goes to my name, it's there, and then I am how many years old? 25, goes in there, goes in here. But the difference between these two seemingly identical definitions is this new say hello function only looks like it takes one input versus the say hello age also takes one input. So if I comment out this original say hello that I had at the top and I rerun this, see down here, I get this weird error, right? It says say hello, which is this new function, takes one positional argument, which is my name, but two arguments were given. So does the reason why I'm getting that error make sense? Are there any questions about that? Okay, I'm gonna assume no. So what do I have to do in order to actually run this modified say hello function? So the first thing I need to do is create a new function. And we can say, what do we want to call it? We could say, or it's not even really it's sort of a function. We could say like say hello to Bob would equal say hello. And what's the input for say hello? It's my name. So we would say Bob. Now, if I try running this on its own, see what we get. So it just outputs a function. So this is still a function, but if I add in parentheses, we can see here that I have to add in a value for my age. Why? Well, yeah, so say hello to Bob is running the say hello function, which is this guy. Now, in order to run, what does say hello do? Well, say hello inside of it defines this function called say hello age, and then it returns that function. So when I'm running say hello Bob, it's saying, all right, I'm going to run this function. My name is Bob. Now I'm going to return say hello age. But say hello age takes in an additional input. So what I have to do here in my say hello to Bob function is now specify the input for his age as, let's say, 12. And if we run this time, we see here, it says, hello, my name is Bob, I'm 12 years old. So why is this setup useful? Well, let's say that we have a bunch of people whose name is Bob, right? We have one who's 12, one who's 245, not sure how they're still around, but apparently they are. We have another who is -10. Don't know how someone can be a negative age, but for purposes of demonstration, it works. And if we rerun this, again, we see here, we say, hello, my name is, and then Bob, right? Because that's what we said in this original syntax. I am however old he is. If we were to use the old syntax that we had for say hello up here, what we would have to do every single time is say hello, Bob, 12, then say hello, Bob, 245, and say hello, etc. And you can see how that's not the most helpful thing. The other approach we could do is we could modify original function and say that my name equals Bob, unless you put in, or I guess we could just say hello, my name is Bob in here and delete my name, or set my name as set the default value of my name. But do we really want to do that? Not necessarily. It depends case to case. In this case, we don't want to set a default value. We just want to leave the option open to put in whatever name you want to introduce. So in our case, again, we chose the example of Bob, but we can also, again, instead of just saying say hello to Bob, we can also use this to create a say hello to Alice function, or a say hello to Charlie, or whatever you want to introduce. So by using this currying method with these nested function definitions, it lets you introduce more flexibility, but also reusability for your parameters. So again, you're still running this exact function every single time. But if you need to create like 5 entries of Bobs who all have different ages, this approach is a lot easier. It's not necessarily easier, it's a lot cleaner to use. So does that kind of make sense? Any questions about how this works?
What about when there's, I guess, more than one argument? Do you just take them in order or assign the order that you want for the multiple arguments if you're going to use one that doesn't just take a single parameter?
Okay, that's a good question. Let's try that actually. So let's say we have my age and then R. Say I like R. So if you're talking about multiple inputs like this, we should hypothetically be able to add in more inputs into here. So we could say Ferraris and it's like tell you what it is. And we can delete this. Something that's probably a bit too many. So if we run this now, once it runs, we can put in a second input into our, for example, say hello age function in here, right? So this way, again, because we're saying hello to Bob, it's generating everything with my name equals Bob, and then you can customize my age and car. Now, however, we can also do it the other way. Now we can add in another input in here. We can say like my last name, and then we could say like Bob Builder or something. Then Alice Wonderland. So now we have to put in 2 inputs into our base function, but now every single time we call say hello to Bob, it's going to preset and it's going to remember, hey, every time I call this, I'm referring to this guy whose name is Bob and his last name is Builder. So you can add in multiple inputs to any level, I suppose, of the function that you're currying.
For the currying, like there's basically a function inside the function.
Yes.
Where do you stop currying? Like a function within a function within a function, so on and so forth? Does it get pretty convoluted?
You can basically curry for as long as you want. There's not really a limit to it.
So for this example, we could technically curry car in there instead of passing it as a second parameter. We could curry
Yep.
that as well.
Yep, we could do that if we wanted to. But again, you can curry things as much as you want. In theory, but in practice, it starts to look a little bit ugly. Because there becomes a point where it's like you can technically curry every single input, but then you start getting like weird syntax when you have multiple curried arguments, I suppose. So let's see if we can try. So we could, for example, say print, say hello, and then we can take in our first argument, right, which is my name. So we could say person, and then last, no, still getting used to this keyboard. And then we have a last name. But remember that say hello, what does say hello do? Say hello returns this age function, which has two other inputs. So if you want to do something that calls the entire function in one line, then we have to add in a new set of parentheses, because that new set of parentheses are the inputs for say hello age. You can say like the age is 1, 2, 3, or is. And if we were to run this, once it runs, again, we can see here, my name is, right, person is the input to say hello, right? Age, or well, last name we don't see. Age is the input to here, and car is the input to car. But the only way that we can make this work is if we stagger out our inputs using these parentheses, because again, these two are the input to say hello. The last two are the input to say hello age. So yeah, we can keep staggering these as much as you want, but it just looks really ugly, and also it takes up a bunch more lines.
Yeah, and I guess it's kind of like list comprehension is really useful, but maybe once it gets to a certain point, it becomes somewhat unreadable.
Pretty much.
More confusing.
Yeah. And again, like, this isn't something that we really use all that often. It's more common to not define functions within each other necessarily, but I feel like generally you'll see people calling functions in a nested fashion, not defining them as such. But there are some good examples of using curried functions. Let me see if I can find a good one.
Isn't that
So
how
yeah.
like a map is kind of written?
Kind of, yeah. They act sort of similarly. So again, map takes a function and another output, and then it just runs that function on whatever thing it is that you're inputting, which is usually like an array or a list, I guess, in Python, or a dictionary or whatnot. We could probably come up with a curried version of map. But it probably wouldn't be very helpful. Here's a good one. So we can create a function that composes two functions. So here, let's see if I can find, yeah, there we go. So this is here, I'll send you guys the link if you guys are interested in getting deeper in the weeds for currying. I popped it in the Zoom chat. So we can create a function that composes two functions. So in math, right, you can have like a function like f of x and then like g of x. Then you can make the function like f of g of x, right? So that's basically what we're going to try to do here in Python. So we could say define like compose, and then it takes in, let's say, function 1, and then function 2. But now inside of this, we want to create a subfunction. We could say that this subfunction is like H, I guess, I think is what they called it. Don't exactly remember. And then this takes in the input of a second function, and this is going to return function 2 of function 1, if I remember right. Function 1. So, and then down here we would turn H. So this is like the general structure of if you have, let's say, a function that you want to combine or use as the input for another function. But we want to be able to generalize our functions. So actually, let me go back and change this a little bit. So function 2, function 1. So we also want to say here that you can take in arguments and args. Let's see, does that? Oh, let me do. There we go. So have you guys talked about what args and quargs are before?
No.
Okay. Has anybody heard of these before?
I think the asterisk args mean you can return, is it either as many arguments or you can place as many arguments as you want, or something like that. I'm not quite sure, but I briefly remember.
Okay,
Yes.
yeah. Oh,
I've
go
seen
ahead.
it before, and like I know the first part he has right, like is you can definitely put as many arguments, and then all I really remember is that quargs is keyword arguments. But I don't, yeah, I'm kind of lost on it.
Yeah,
Is it like
pretty
arguments
much.
You could put in from the command line or something.
Kind of. So this is good. This takes up more time, which is good because today's lecture was kind of short anyway. So, all right. So when we define a traditional function, right? Let's say this is an I am a function, and then we have like input 1, input 2, and then we can have like return output, right? So this is like the normal way that we define a function. And we can continue adding inputs, right? We can say like we have input 2, input 3, input 4, blah, blah, blah. But sometimes we don't know the number of inputs that we need to include in our function. So what's an example that I can find? Yeah, this is a good one. So let's say that we are creating a sum function, right? So we have find sum of numbers, right? So the easy way to do it would be like we have number 1, number 2, number 3, number 4, and so on, right? But again, what if we don't want to just sum 4 numbers? Let's say we want to sum like 30. Well, an easy way to do it would be to get a list of numbers, right? So you could put input, let's say a numbers list, and then we could just say like for I in numbers list. Okay, let's also define output equals 0. I in numbers list, we have output plus, no, output plus equals I. Right, so this is like the easy way to define the sum of numbers. But let's say that we don't want to have to be forced to input a list, right? So the only way that sum of numbers would work right now is if I wrote, let's say like 1, 3, 6, 7, like so. But let's say I don't want to do that. Let's say I want to be able to run this like I would run a normal function, like 1 could be an input, and then we have like 12 and -10 and so on. How can I do this? Well, this is where args come in. So I can do here is we can call this args and make that an argument. And what args does is args creates a tuple for us that we can use. So let me copy paste this, and we can also print args, just to show you guys how this works. Let me also comment all of this out since we don't need that. And oops, there we go. Nope, no slash. There we go. So as you can see here, so we ran what we put input 1, 12, and 10, just like we would input it to a normal function, right? Not in a list or in a dictionary or anything. But by using args, as we have here, it creates a list of arguments, or a list from the arguments that we gave it. So I could technically delete this and make the list a number of arguments in there blank and rerun it. And then the arguments variable here is 0, or it doesn't have anything in it. Similarly, I can add arguments to this. We can run it, right? And then it just adds to our list of arguments there. So does that kind of make sense? Any questions about arguments?
It makes sense, but why is it not returning the output?
Oh, it is returning it. I just didn't say print. So yeah. So if you wanted it to print out the sum, then we just need to say print, and it prints out the sum for us. I just didn't write the print.
Cool.
I guess like what's a real life application for this? I'm trying to think of one off the top of my head. Because I'm thinking like if you pull data from an API, you would typically save it in some kind of object, right? Or maybe like a JSON, and then from there, why couldn't you just use a variable rather than multiple arguments like this, if that makes sense?
That is a good question. I think that's actually a good question. Personally, I don't recall a specific like real world instance that oh, actually, no, here's a good. So let's say that you have a database, right? Like in your case, and you need to run a function on various entries in your database. So each entry in your database comes out as, let's say it comes out as a list, right? And you need to run some specific operation on each row of your list. But let's say that this operation could rely on not just one row, but it could use 2 rows or 3 rows or like 6 rows. And you don't know and it's application dependent. So that's where you can use args like this. So for example, like we have here with our sum of numbers, right? You can sum 2 numbers together, you can sum 4, and sum 100. The function itself is the same, but you add in that flexibility if you need it to be like, okay, I can now use this sum of numbers in any application. So let's say that we're running the sum of numbers in a web page, and we said, all right, user, give me 2 numbers. And we had our function that printed out the sum of 2 numbers. Then somewhere else on our web page, we had something that printed out the sum of 6 numbers. Do we really want to have to write an entirely new function to sum 2 numbers together and sum 6 numbers together and sum 13 and so on? It's kind of silly to keep writing new function definitions for functions that do the exact same thing, but just take in a different number of inputs. So that's where arguments really come in handy.
That makes more sense. Thanks.
Yep. Any other questions about arguments before we move on to quarks? Okay, so now that we talked about arguments, let's say do I think an example I remember seeing was like a concatenation function that used args like so. So what's the difference between an arguments and quargs. So quargs is just a short form that basically says quargs equals keyword arguments. So all this means for us is when you're running this function, basically you just need to create key value pairs. So you could say like A equals hello, then B equals I am a thing. And again, like when we're running this function, here, let's just say turn like that. So this lets you take in an unlimited number of, I guess you could call them like named variables, might be one way to say it, or key value pair arguments, like so. So, and let's say we created like a more complicated variable name. I don't know. Juice color is. So, oh, that was not supposed to be there. And then we can print this, so that way we can see the quargs that are coming out. Oh, no, stop running that. No, there we go. So we can see here that when we run it with quargs, it creates a dictionary for us that creates, well, key value pairs, right? So we have the key is A, it's hello. The key is B, the value is I am the thing. The key is juice color, the value is blue. So quargs basically let us take in an unlimited number of keyword arguments that are, let's say, optional, right? So what we could do is, that's a good way to do this. Yeah, let's say that we have like phrase 1 and phrase 2, and then a bunch of quargs. So we could say like, hello, I am a thing, and then our juice color. So if we run this, so hello is going to be our phrase 1. I'm a thing is phrase 2. And then everything else, everything else in our quargs are going to be our key value pairs like this. So what's a useful application of quargs? Well, what we could do is do something like if, let's say, what's a good way to do this? Yeah, I guess we could say like quargs of juice color equals blue, then we can say turn blue. Otherwise, look, that was not supposed to happen. We return like phrase 1 plus phrase 2. So if we were to run this, we have, again, quargs are our inputs here. And juice color is the optional variable that we're inputting. So what we're saying is if quargs of juice color, which is this optional argument, does it exist? It does. And if it's blue, it returns blue. But what if we said that this was red, for example, and we wanted it to do something different? Well, if it's red, then it returns hello, the thing. But what if we didn't even, what if we were running this function somewhere else that doesn't even use juice color? And we're just running phrase 1, phrase 2. And instead of juice color, let's say that our function now needs some other input. We could call it like light color. And we could say that is. And if we run this, again, we have our phrase 1 is this guy, phrase 2 is this, and our quargs are this light color thing. So quarg shouldn't have juice color in it. So it'll just return the concatenation. And if we run this, we see here that we get a key error because juice color is not part of our keyword arguments. So a useful use case for quargs is when you have optional arguments that you could pass in, or an unlimited number of optional arguments that you could pass in. And using key value pairs like this, you can check whether or not those unlimited variables that you're passing in match up with specific ones that you're looking for. So there's a little bit more niche than just regular args, but are there any questions about what args are exactly?
No, but like I guess you could probably use it for like something like the Roman numeral problem, like instead of building the dictionary, maybe you could just pass a bunch of key pair values as quargs and then run the code that way instead. Or
You could, yeah. So for the Roman numerals problem, instead of saying like, let's pretend that say X didn't always map to 10, right? X could map to like 36, or V could map to like -3 or something like that. So if you were to make a Roman numerals problem that you wanted to generalize like that, then quargs would probably be helpful in that sense. There's some other good examples of quargs that we can use. Yeah, it's hard to come up with use cases on the fly, but just know that args are used very commonly. Quargs are used slightly less commonly, but they're still very important. So anyway, that was a slight detour on args and quargs. So what did we cover so far? So we did function composition. We talked about currying. Oh, right. We do need to talk about decorators. All right. So have you guys worked with decorators before?
I can't remember. Is it similar to like a static method? Or like, I know there's an @ sign, but I kind of forget what they do.
Yeah, so they're pretty similar. So essentially what a decorator does is it lets you create a function based off of what another function does. So it's really similar to currying, but it kind of works the other. I guess you could say it kind of works the other way. So let's say that we want to make a function that runs a function and then prints out the function is done. So we could say like prints complete after function run. That is a very complicated function name. Please do not name your functions with that complicated language, but for purposes of this demonstration, it should probably be fine. So we'll define our function. It's going to take in like some function as its input, and then it would run some function, and then after that we print function is done. Now let's say that we have define like a countdown function, and then we could say like count from, right? And we can just say for in range 0, comma, or I guess we could do, but I need to count from, and then 0. The step could be like -1. We would just print I, right? Just like a really simple countdown function. So let's say now that I wanted to, well, let's say that I wanted to print out the function is done after I'm done with our countdown. So how can I do this?
Could you do @ and then the really long function name, and then call the function, the countdown function below that?
All right, let's try that. So we can do print complete after function run, and then countdown like that. And if we run this,
I was saying like an @ symbol in front of that without any parentheses afterwards.
oh, so you're talking about like this?
Yeah, something like that, maybe.
Okay, all right. So that might work, except now we have a very tiny problem. And if we mouse over this, we see again, it said, what does the error message say? It says expected function or class declaration after decorator. So it recognizes that print complete after function run is a decorator. But the problem is that it expects us to have some function created or returned or something within this defined print complete after function run. So we need to create basically a wrapper method inside of here that doesn't take in any inputs and then return that wrapper. At least that generally should work. Let me just make sure I haven't mixed up my formatting here. Oh, here's why. There we go. That needs to go there. Perfect. And if we run this now, all right. What is this error saying? Print complete after function run locals wrap. Okay. Here, we'll just say that this starts at 10 to avoid that error happening. We'll talk about how to put in arguments to this after. So if why is it still saying that? It's complete. Let's see, where are you? So you're there, and we're running it as countdown.
Is it because you're passing in a parameter at the bottom and then the function is not taking in a parameter?
That actually might be it. Thank you. There we go. Appreciate that. I was going through every single line of this. So thank you for that correction, Ken. So how does this function work? So again, we're running countdown here. So if we go to countdown, it says, all right, for I in range, so we're going to go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. But by putting it by using this decorator for it with our wrapper function, some func here is replaced by countdown. So it runs countdown, and then afterwards it runs this print function is done. So that's how our wrapper function works. So we could easily replace this countdown function with some other function if we wanted to.
Just for sake of visualizing this all, let's say if you're not to use a decorator, how would you how would it look to call that function, I guess?
Without a decorator.
Yeah, so if you want to get the same answer in the terminal without calling the decorator on that function, isn't there some sort of way to like kind of like call it in another way?
So I guess, yeah. So what you could do now that we've like defined our function, you could either use the decorator using the @ sign, or what we could also do is say countdown and then redefine countdown as, what's the right order to use this in? Here we go. Oops, and delete that, like that. And we could say countdown equals, and delete that as such. So if you don't want to use this like fancy decorator notation, you could also like literally nest the function within the decorator, which does the same thing. So the syntax is just a little bit easier to use, and it's honestly more visually appealing than this one. But that's another way to do it if hopefully that answers your question.
Yes, it does. Thank you.
Yep. What other things can we talk about for decorators? So again, decorators are functions, right? As we can see by our define. So that means we can do normal function things with them. We can import and export decorators to other files. We can also let them take in arguments. So now let's let's say our countdown function again. Let's go up here and let's take that out. And let's say now that our countdown function takes in input number or start num. And we're going to start off at 10. So if we were to run this one more time, hopefully shouldn't get any errors, and we don't. So now if I were to run, let's say, countdown 10, this should probably work, right? Because, yeah, we're passing in our input, passing in the input here, passing it in there, and then this runs that function. So it doesn't look like there's anything seemingly obvious that will go wrong. Very wrong. There's a huge problem. And the problem is if we look at our type error down here, it says that our wrapper function, which is this guy, takes in 0 positional arguments. Why does it take in 0 positional arguments? Because this thing is completely blank, but it says but 1 was given. Well, where did we give our wrapper function an input? That doesn't make any sense. It looks like we're just giving countdown, which is this guy, an input. Well, remember that this thing, countdown function, is part of our decorator, or is being decorated by our decorator. So we are implicitly running our wrapper function when we're running countdown. And this 10, as an input to countdown, it's being input into our wrapper as well. So how do we fix this weird problem that we're getting? And this is where Args and Quargs come into it. So we do Args, and we put this in here. This should solve our problem. Can anybody tell me why this statement that I just added may help resolve our problem that we're getting with our type error?
Because it should make it to where the number of arguments is irrelevant, or if you can pass it none or infinity.
Yep, that's part of the explanation. The other part is that now this also allows us to pass this 10 not just into the wrapper function, but pass it to some function or function that we're running as well. And it lets us pass in as many inputs as we want. Why is that helpful? Well, a wrapper when we're designing a wrapper function, we don't just want wrappers and decorators. If we're designing a decorator, we don't just want that decorator to be applicable to one function, like our countdown function. We want our decorator to be something that we can use for a range of different functions. So let's say, here we have this countdown function, right? We could also define another function, and we could call it some 3 numbers, and we could say n1, n2, and 3, and then we could say print n1 plus n2 plus n3, right? So this thing takes in 3 inputs. And if we want this to be decorated by our prints complete after function run decorator, well, we have 3 inputs now, 3 arguments. That works here because we have a little star before the arguments, which means we can take in an unlimited number of arguments and pass those unlimited number of arguments from our original function to the wrapper, to the original function, and then return all of that. So if we run this code now, once it runs, and again, we see here that we get our nice, neat little countdown in the left. So we can pass, even though this is 1 input, because countdown only takes 1 input, it says, I'm going to take as many inputs as I'm given and just pass those right along to some function. So that way we can reuse our decorator for as many functions as we want.
Is this used for like error handling?
You could. You definitely could use it for error handling. Personally, I haven't seen currying and decorators used all too often outside of really just pure instructional context. But you definitely could. I mean, what you could do, for example, here is say, like, let's say you're running your function outputs, let's say, a type error, but you know that type error isn't something to be worried about. Then you could create a wrapper function that checks, hey, is the output of this function a type error, or is the output of this function like some really weird value? If it is that some really weird value, then print out like, hey, this is a problem or something like that. And again, you can use this wrapper on any function that you create if you wanted to design an error checking, error handling wrapper like that.
Could you talk about why the wrapper function is important again? I'm kind of losing that one. Because why did you need the wrapper function instead of just having some func and then arguments and keyword arguments?
Sure. So let me go back here and let's just there. Okay, actually, I'm gonna copy this and comment this just so that hopefully still works. So if we remove wrapper and we just go back here and do that, and let's say we just ran this as it is. Number one, we get this problem. Args is not defined. So we need a way to pass in our arguments that we pass into some function. We don't have a way to do that currently. But let's say that some function never even took any inputs, right? Like hypothetically speaking. So we remove start num, have this started off at 10. The only problem is if I were to run this now, it runs. No, sorry, let's delete the 10 there. Run that. So the problem that we get here is, well, one, it says none type object isn't callable. Why? Because of, well, print complete after function run. This is just a regular function, and we can't use this notation now to describe our decorator. So let's say we go here, no, come on, stop. There we go. All right, so this helps, hopefully going through the error messages helps show you in a little bit more detail. If it's confusing at all, please let me know. So let me clear this, actually, just to clean things up a little bit. Okay, so we have a problem here that says prints complete function run, which is this guy. Or here it says some func, and it says type error, none type object is not callable. So it has a bit of a problem because it doesn't know what to return. So when we were doing this a little while earlier, because we've defined it using this decorator notation, we have to have a wrapper function because otherwise it doesn't know what the decorator is supposed to do. Otherwise, if we didn't have this attached to it, what we could do is, there we go. Let's try that. And here, let's delete this and run that. So again, as we can see this right here, right? We're running countdown. We're saying it prints complete after function run. So it runs this guy, and then we input it to our sum function that says, all right, the function's done. Nice and easy. But this doesn't really change our function definition at all. It just runs it. So if we want to use decorators to change the behavior of our function, well, one, we have to use the decorator notation. Let me back up. Oh, no, I went too far. So one, we have to use the decorator notation, which is using the @ sign. And then the second thing is we need to use the wrapper function. Because if we don't use the wrapper function, then we get the error that the decorator is not returning another function. So that's the entire reason why we use it.
Okay, that makes sense. Thank you.
Yep. Any other questions about how decorators work? I understand that these can definitely be confusing. So if you have questions, please feel free to ask.
Does the Does the flexibility of using like args actually like make error checking harder, or like because there's like more data types that you would have to potentially look for or watch out for?
I guess you could say it does make your job a little bit harder when it comes to that, just because you've, like you said, you have anybody can basically input anything. So this is why it's never a bad idea to check your data types once you run, or like the moment that your function is created. So something that I like to do, and especially if I'm writing a function that I know I cannot have break later, or that like somebody needs to, for example, like you have to write an integer, is I'll define my function, define my inputs, and then like the first line of the function. All right, is input 1 an integer type? If it's not an integer type, throw an error. Input 2, is input 2 whatever type I'm looking for? If it isn't, throw an error, and so on. You can also do that with arguments, because again, let me comment this out, and let's see, here. Yeah, we can do that. And then let's real quick, we can do sum of numbers, let's say like 1, 11, 15, something like that. And if we run this real quick, so when you put out args, it returns a tuple, which is essentially a list. So if you want to make sure that all the arguments you're getting passed fit the data type that you're looking for, using the sort of for loop format like we are here, like for I in args, you can check like, hey, is I an integer type? If it is, great, move on. If it's not, throw an error, and then just check every single argument that way. So it does make your job for quality assurance purposes a little bit more difficult, but there are relatively easy ways around it, if that makes sense.
It does. Thank you.
Other questions?
So I'm looking at the example on the GitHub, and I noticed that under the decorators, the example they give us, they didn't really use wrapper. So is there any situation for decorators that you don't really need to write down the wrapper function for it to work?
Here, let me switch, because they should definitely be using wrapper functions in there. Where's my Chrome window? Okay, can you guys see the GitHub? Okay, cool.
Yes.
So, Joyce, I'm assuming you're referring to these examples?
Yes.
Okay, so they do still use a wrapper function in here. They just don't call it a wrapper function. Here they're just calling it an
Gotcha.
inner function. Yeah. So the name of it doesn't really matter, because wrapper or inner, I don't believe, are protected keywords. You can call them whatever you want. But here they're calling it inner. The way that you know that this is a wrapper function is, one, it just takes in a bunch of arguments for your function. And number two is the function that you're running, like the outer decorator, returns this inner function that you're running. So that makes it basically a wrapper function.
So for a wrapper function, well, actually for the decorator, when you use it, it will always return the wrapper function then for it to work?
By design, that is what you should do. Because that way, again, so going back down here, right? So once you do the at once, then cell becomes an input to your decorator for once. And then your arguments here are whatever you pass in to cell. And then it runs all of this stuff. But you need to run the final result of your wrapper function. And then that's what this does. So by definition of how the wrapper function works, or how the decorator works, you need to have like a outer decorator function that you pass other functions into by using that at notation. And then you use the wrapper to actually do all the stuff you need to do with that function.
Thank you.
Again, I recognize that this is really confusing, but there isn't really at least as far as I'm aware, a very simple way of explaining it. But if I find one, I will definitely send it to you guys.
Sounds good.
Any other questions I can try to answer before we move to problems? Okay, I'm going to zoom not right now. So today's problem, you've only got one, but it's a little bit weird. So this is going to be a problem with decorators. It's called even seconds. And basically you only want to, the function should only run if your program is executed when this time of execution's seconds number is even. So yeah, like it says here, if you're running at 10, 23, 55, you don't run the original function, like you return like none. But if your program, for example, is run at like 7, 37, 12, it should. So you'll have to create a deck, again, looking back at this example right here, using like the once and inner is probably going to be your best reference, but you're going to want to create a broader decorator function and then figure out how to get your system time. Then once you get your system time, figure out how to manipulate it somehow using this inner wrapper function to either run the function that you're inputting or not run the function. So this is your one problem for today. Let me stop the recording in the meantime.